Students, in previous class we have completed Mathematics 2B, System of Circular Objective until level 2 homework you have completed. Now today the topic is Mathematics 2A. In Maths 2A I want to discuss with you today the topic is quadratic expressions. First of all, let us complete IITJEE theory, concept and sums. Later we can discuss about the objective. The quadratic expressions chapter in Mathematics 2A, according to IP weightage is 2 plus 4 marks. 2 plus 4, 6 marks. In MSET, you will be getting 1 or 2 bits. In mains, only 1 bit. Next chapter of quadratic expressions or equations. Another chapter is there, the chapter is theory of equations. In mains, the question will be giving from quadratic expressions and theory of equation all together. Only 1 bit you will be getting in mains. In advanced, you will not get the question in quadratic expressions. In advanced, you will be getting a multi-concept question from all together quadratic expressions, quadratic equation, theory of equations, everything. Only 1 bit in paper 1 or paper 2. We cannot say properly. That will be decided later. But in mains, this is important topic. Compulsory bit is there from quadratic expressions in mains. Okay, now let us going to discuss about the quadratic expression. Put side heading quadratic expression. Okay, let us going to discuss about a polynomial. Later we can discuss about quadratic expression. First we can write the definition of polynomial. Later we can discuss about quadratic expressions. Put side heading polynomial. Polynomial. An expression f of x is equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on, r x power n minus r plus so on, an minus 1 x plus an is called as an nth degree polynomial or polynomial of degree n. An nth degree polynomial or polynomial of degree n. Here an not equal to 0. Here a naught. What is the highest coefficient is there? It is called as leading coefficient. Here a naught not equal to 0, not an. Last an may be 0, no problem. An not equal to 0. An expression f of x, it is denoted by f of x, an expression which is in the form f of x equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus a3 x power n minus 3 like that so on. an minus 1 x plus an is called as a polynomial of nth degree polynomial of polynomial degree n. Here a not equal to a not equal to 0. This is a naught. So whatever the coefficient of x power n is there, it is a naught. Here a naught is called as, here a naught is called as leading coefficient of x power n. coefficient of x power n. First of all, I said that nth degree polynomial. This definition you can learn in next chapter, theory of equations. Now only I said because the quadratic expression means it is the leading coefficient which is having a 2. Quadratic means the coefficient of x square should be leading. So that is called as quadratic expression. In the polynomial of nth degree, the degree should be 2. Whenever the degree is 2, such polynomial is called as quadratic expression. That is the definition from polynomial definition. Now let us discuss about next definition. Quadratic expressions or quadratic equations. Here in the polynomial definition, so many coefficients are there, a0, a1, a2, a3, so on like that. X power n, and x power n is the coefficient of large coefficient. Next, the term power will be reduced like this, x power n minus 1, later x power n minus 2, later x power n minus 3. At last there will be no x term. Like that, it is called as simply polynomial of degree n. In the polynomial of degree n, you have observed that first, second, third coefficients are simply constants. So depends upon the x term or degree of the x term, only coefficients will be dependent. a0 x power n, next a1 x power n minus 1 plus a2 x power n minus 2 plus so on like that. In the next definition, quadratic expression. Quadratic expression. We can write like this: an expression which is in the form of f of x is equal to ax square plus bx plus c. That's all. Where a not equal to 0, a comma b comma c are real or complex numbers. Real or complex numbers. An expression which is the form of f of x plus ax plus b plus c, where a not equal to 0, a, b, c are real or complex numbers. This is the condition. Is called as quadratic expression. Is called as quadratic expression. If f of x is equal to ax square plus bx plus c is equal to 0, then f of x is called as a quadratic equation. A quadratic equation. The expression ax square plus bx plus c equal to 0, where a not equal to 0 and a, b, c are real or complex numbers. So maybe real or maybe complex, or real and complex both we can say. So in such condition, the term ax square plus bx plus c is called as quadratic expression. Whenever is equal to is there, then it is called as equation. For every term, for a polynomial or monomial or binomial or trinomial, if you write simply without equal to 0, it is called as expression, and whenever you put is equal to 0, it is called as equation. Already you have learnt in 8th class or 6th class itself, I think. Now we can discuss about this question as f of x plus a square plus b plus c equal to 0. Whenever you put is equal to 0, for the expression it becomes an equation. It is called as quadratic equation here, which is of the form ax square plus b plus c is equal to 0. Here A is called as coef of x square or special name is that quadratic term. Quadratic term. And B is called as coef of x, or it is called as linear term. Linear means mono, that means power of x should be 1. So x power 1 is called as linear term. So C is called as simply constant. This is a constant or constant term. In the expression or equation, no problem, you can say for both. A is called as quadratic term and B is called as linear term and C is called as constant. Now let us going to discuss about the solution of the quadratic equation or quadratic expression. You can put side heading now, solution or root or 0. Solution or root or 0. Now we can write a real or complex number. Somebody used to say simply complex number. A real or complex number. A real or complex number alpha. A real or complex number alpha is said to be a root or solution. Is said to be a root or solution of a quadratic expression. Hereafter QE means you can understand whether it is quadratic equation or quadratic expression, no problem. Of a quadratic expression, a real or complex number alpha is said to be root or real or quadratic expression if it satisfies that expression or equation. Let us take an example. First of all, we can take example for a quadratic expression. Example for quadratic expression: x square minus 4x plus 5 and x square minus of 2 plus 3i into x plus 3 square equal to 0. Of course, this is an equation. This is expression like that. X square 5x square minus x root 5x plus 5 root 5 equal to 0. Students, I am writing here simply real number model, and this is complex number model, and this is rational model. Anywhere you can take an example. Simply these are the examples of quadratic expression. This is expression, this is equation, this is equation. Now let us going to discuss about root. Root or 0. What is 0? 0 or root or solution is nothing but same wherever the equation satisfies with the given complex number or given real number. Example, let us consider f of x is equal to x square minus 4x plus 3. Now you can write here f of 1. Substitute 1 here. It becomes 1 square minus 4 into 1 plus 3. So 1 minus 4 plus 3 becomes 4 minus 4 equal to 0. Satisfying meaning is that you should get the answer as 0. This is quadratic equation. Therefore 1 is a root. Here we can say that 1 is a root of given QE. 1 is a root of given QE. Let us take another example. G of x is equal to x square minus 5x plus 6. Now what you can say? Is equal to 0, you put no problem. Here g of 2 you can take. This is called as verification by trial and error method. I am trying whether it is okay, it is right, whether it is error, you can say it is error. The method is called as trial and error method. Don't write here 0. Now we should get the value whether it is 0 or not. If it is 0, it is satisfying, otherwise it is not satisfying. You can write now 4 minus 10 plus 6. So what is happening here? 10 minus 10. 10 minus 10 equal to 0. Therefore, you can say that 2 is a root of. 2 is a root of given QE. Here what is QE? Here QE means quadratic equation and here QE means quadratic expression. Whenever he given as it is equal to 0, you should get the answer is equal to 0. Whenever by substituting the real or complex number anything. Here 2 is called as a 0 or 2 is called as a root or 2 is called as a solution. Here you can understand f of x square minus 4x plus 3, simple it is expression. Whenever a number is satisfying, what is meant by satisfying? The answer should be getting 0 whenever you substitute the value. Then whenever you are substituting 1, it is becoming 0. Whenever you are substituting 3 also, it becomes 0. Yeah, 3 also it becomes 0. So this meaning that the real or complex number which satisfies the given quadratic equation or quadratic expression is called as a solution or root or 0. Now let us going to discuss about quadratic identity. Quadratic identity. Quadratic identity. Until 10th class you have learnt about identity. Among the identity there are two types. One is additive identity and second one is multiplicative identity. To get the additive identity, we can understand that if a number added to a given expression or a given number, you should get the same result. Example, you take 5. You should get only the answer is 5. So which number is added to 5 to get the 5? Which number is added to 6 to get the 6? So same answer you should get. That meaning is identity. So what is identity means? There will be no change in the given expression, even though you are adding. So what is happening? Example 5 is there. You should add 0 to get the result 5. Example 6 you take. You should add 0 to get the result is 6. Now ax square plus bx plus c is the expression. You should get the same expression ax square plus bx plus c. Then what you should add? Simply 0 only. But you should try to understand that 0 in the way that 0 into x square plus 0 into x plus 0 is called as quadratic identity. 0 is right like this. 0 into x square plus 0 into x plus 0. That is nothing but 0. That is 0. But you should write like this. 0 is called as a quadratic identity. Is called as quadratic identity. Example you take like this. 5x square plus 6x minus 7 equal to 0. This is f of x. Find qi. What is qi? Quadratic identity. So you should get the same answer. You should write like this. 0 into x square plus 0 into x plus 0. That's another equal to 0, otherwise simply 0. Is quadratic identity. That's all. So whenever you are adding the same answer. X square coefficient x square coefficient should add, and x coefficient should add, and constant you should add. So here 0 into x square plus 0 into x plus 0 is called as quadratic identity. Now let us calculate the roots of quadratic equations. Finding the roots of quadratic equations, put side heading. Roots roots of quadratic equations. Expression is right. Expression or equation, anything. Let f of x is equal to ax square plus bx plus c is a QE. Therefore, quadratic equation I am writing. Quadratic equation is ax square plus bx plus c equal to 0. Quadratic equation is ax square plus bx plus c is equal to 0. So whenever ax square plus bx plus c is equal to 0, then we can understand that here if alpha is a root, let you can write alpha be the root. Let alpha be the root. Alpha be the root of the expression ax square plus bx plus c is equal to 0. That implies you can write here as a alpha square plus b alpha plus c equal to 0. Now you write as multiply both sides by 4a. Multiply both sides by 4a. You will be getting like this: 4a square alpha square plus 4ab alpha plus 4ac is equal to 0. We can understand here I am writing add comma subtract. Add comma subtract by 4b square. B square is enough. Add comma subtract by b square. So you can write 4a square alpha square plus 4ab alpha plus b square, take a bracket like this. Now you can write minus b square plus 4ac equal to 0. That implies this is of the form a square plus b 2ab plus b square model. You can write here as 2a alpha plus b whole square is equal to this one taken right side, it becomes b square minus 4ac. 2a alpha plus b whole square is equal to b square minus 4ac. That implies we can understand this one as 2a alpha plus b is equal to taking square root. Whenever you are taking square root both sides, it becomes plus or minus root of. Now 2a alpha is equal to plus b taken this side, it becomes minus b plus or minus root of b square minus 4ac. And here you can write alpha is equal to minus b plus or minus root of b square minus 4ac whole by 2a. Alpha is equal to minus b plus or minus root of b square minus 4ac by 2a. If, now I am writing, if alpha comma beta are two roots, if alpha comma beta are two roots of given QE, means given quadratic equation, among them you can write using this one as alpha is equal to minus b plus root of b square minus 4ac by 2a, and beta is equal to, you can write this one as minus b minus root of b square minus 4ac by 2a. Minus b minus root of b square minus 4ac whole by 2a. Here we can observe two things, that a quadratic expression having roots as alpha is equal to minus b plus r is root b square minus 4ac by 2a. And a quadratic equation having two roots, that first one is the plus case and minus, second one is minus case. Among them, first one is alpha is equal to minus b plus root b square minus 4ac by 2a, and alpha, it is denoted as beta, another root, minus b minus root of b square minus 4ac by 2a. So we can conclude that a quadratic equation having two roots. The roots are minimum two roots. There is no minimum maximum. Two roots rule, two roots should be there. So what, there is no roots or there is no chance to zero root, there is a chance to one root. This is called as equal root concept. That is going to discuss in next topic. Now you can write here a quadratic expression or a quadratic equation having two roots. Maximum two roots, minimum one root only, that is in equal case. Note you can write. A quadratic equation has minimum to maximum, not minimum. A quadratic equation has maximum two roots. There is no question of roots are real or distinct or complex numbers, anything. Two roots, that's all. I am not discussing about the nature of roots now. Simply quadratic equation can have maximum roots is 2. Can have maximum 2 roots. Now we can discuss using the theorem sum of roots and product of roots. Let us going to discuss about sum of roots. You can write here, we know that, now I am discussing for the sum of roots of the quadratic equation only. We know that, write like this, alpha is equal to minus b plus of root b square minus 4ac by 2a, and beta is equal to minus b minus of root b square minus 4ac by 2a. Now, to get the sum of roots, you can write alpha plus beta. Alpha plus beta is equal to, write like this. Add the two roots, minus b plus or minus, plus, don't plus or minus. Minus b plus root b square minus 4ac, minus b minus root of b square minus 4ac whole by 2a. Now plus root b square minus 4ac will be getting cancelled. Here minus b and minus b, you can write minus 2b by 2a, 2 get cancelled, minus b by a. Therefore, sum of roots alpha plus beta is equal to minus b by a. Let us discuss about product of roots. Product of roots. You can write alpha into beta. You can write this one as minus b plus root b square minus 4ac by 2a into minus b minus root b square minus 4ac by 2a. This one you can understand as, this is minus b is a term a and plus this is a term a plus b into a minus b. We know that the formula of a plus b into a minus b is a square minus b square. You can write here b square minus of this root and root will be getting cancelled. B square minus of b square minus 4ac by 4a. Now you can write here by b square and b square getting cancelled method. In numerator becomes only 4ac and denominator is 4a square. 4 get cancelled, a square get cancelled. So product of roots is the formula c by a. Product of roots. Product of roots alpha into beta we can write product of roots is equal to C by A. Now we have learnt about the properties of, simply not properties, we have learnt about the quadratic equation or expression definition, and sum of roots and product of roots we have discussed. We have learnt the definition of quadratic expression, quadratic equation, quadratic identity, root or solution or zero, and sum of roots and a product of roots. Let us going to discuss about nature of roots. Before going to discuss of nature of roots, you should know the term discriminant. Discriminant. For a quadratic expression, ax square plus bx plus c is equal to 0, or whenever expression had it, simply you can write ax square plus bx plus c. Ax square plus bx plus c, b square minus 4ac. b square minus 4ac is called as, b square minus 4ac is called as a discriminant. Discriminant. It is denoted by delta like this, or d. In some usual notation is delta. In some books, in Arihant like that, standard books, they may given it as capital D, delta or capital D. Now we can discuss about the nature of roots. Nature of roots. For a quadratic equation, ax square plus bx plus c is equal to 0. Among them, two cases are there. If small a comma small b comma small c are rational, means a rational quotient, that means 2 by 3, 3 by 4 like that. A rational number is that a number which can be written in the form of p by q, where q not equal to 0 is called as rational number. So if a, b, c are rational, among them, for a quadratic equation x plus b plus c equal to 0, if a, b, c are rational, put aside in it. No write like this. If delta greater than 0, and it is a perfect square, delta greater than 0 and it is a perfect square, then roots of QE are rational and distinct. Rational and distinct. Whenever delta means this one notation, b square minus 4ac is the delta. Whenever delta greater than 0 and it should be perfect square. So what is meaning perfect square? 25, 36 like that. Square should be there, b square, q square, r square, or otherwise simply 25, 36, 64, 100 like that. If it is perfect square, if the delta whatever we have calculated for the quadratic equation, whenever it is a, b, c are rational and the delta greater than 0, then the roots are rational and distinct. Among them, second one, if delta greater than 0 and it is not a perfect square, then roots of QE roots of QE are conjugate surds, you can write. Conjugate surds. Conjugate surds means which are in the form of. Conjugate surds which are in the form of alpha plus I root, not I root, alpha plus root beta, comma alpha minus root beta, like this. These are called as conjugate surds. Surd meaning the expression of the term which is in the form of a plus root b and a minus root b, or a plus r minus root b. Otherwise alpha plus r minus root beta we can write. This is the second case. Third case, if delta is equal to 0, that's all. Then the two roots are, if delta is equal to 0, then the two roots are rational and equal. Then the two roots are rational and equal. That is the third case. Let us discuss the fourth case. If delta less than 0, if delta less than 0, then the two roots are, two roots of quadratic expression. Then the two roots are conjugate complex numbers. Conjugate complex numbers. Conjugate complex numbers which are of the form, conjugate complex numbers which are of the form alpha plus I beta, comma alpha minus I beta. Conjugate complex numbers which are of the form alpha plus I beta and alpha minus I beta. Or the special name is there. Otherwise, or you can write if delta less than 0, next point you can write as delta less than 0. Whenever delta less than 0, the roots are imaginary, then the roots are, you can write like this, imaginary. This is simple term, imaginary. So not real. You can learn the chapter in complex numbers in our 2A topic only. The number which is in the form of alpha plus I beta or alpha minus I beta or alpha plus r minus I beta or a plus r minus ib is called as a complex number. Here alpha comma beta real, I is the imaginary term. So here alpha is called as real part and beta is called as imaginary part. You will be learning later in that chapter. Now, second, among the quadratic expressions, nature of roots, once again you put side D. Nature of roots. If f of x is equal to ax square plus bx plus c equal to 0 is a quadratic equation. F of x equal to ax square plus bx plus c equal to is a quadratic equation if a comma b comma c are real. We have discussed in previous section that a comma b comma c are rational. Now I am going to discuss with you about a comma b comma c are real. Among, put first one, if delta greater than 0, if delta greater than 0, then if delta greater than 0, then roots are real and distinct. roots are real and distinct. Second one, there is no question of perfect square here. Simply if ABC are real, then simply the roots whenever delta greater than 0, real and distinct, whenever delta is equal to 0, real and equal, whenever delta less than 0, conjugate complex numbers. That's all. There is no question of conjugate complex asserts here. If delta equal to 0, then roots are real and equal. You should remember the formula. If delta less than 0, then the roots are conjugate complex numbers. Here you can say roots are equal, that is alpha is equal to beta is equal to minus b by 2a. We can discuss later about this one. Conjugate complex numbers are imaginary roots. Conjugate complex numbers are imaginary roots which are in the form of alpha plus I beta comma alpha minus I beta. I is imaginary, indicates imaginary, alpha is called as real part and beta is called as imaginary part. Now, nature of roots we have discussed. An important topic is there that put note, and we should observe one thing, that a quadratic expression can be represented as f of x is equal to ax square plus bx plus c. A quadratic expression can be represented as ax square plus bx plus c. Now, we can understand here ax square plus bx plus c is equal to, students, take common as a, it becomes x square plus b by a into x plus c by a. X square plus b by a into x plus c by a. In next step you can write this one as x square minus x into minus of b by a, minus x into minus of b by a plus c by a. In next step you can write this one as x square minus x into, we have already proved that minus b by a becomes the formula alpha plus beta and c by a becomes the formula alpha beta. Therefore, hereafter you can understand the quadratic equation, the quadratic expression can be used like this: a into x minus alpha into x minus beta. You can understand this one, if you multiply this one, you will be getting this one, x square minus x into alpha plus beta plus alpha beta. You remember this one as the formula. Quadratic expression can be represented as ax square plus bx plus c is equal to a into x minus alpha into x minus beta. Or in sometimes we may get the answer like this: ax square plus bx plus c by a is equal to x minus alpha into x minus beta. To prove some theorems we can write like this. Now we can write formation of a quadratic equation like this. Formation of a quadratic equation. Formation of a quadratic equation, you can write like this. If alpha comma beta are roots, alpha comma beta roots of a QE, then its equation, if alpha comma beta roots of a quadratic equation, then its equation is like this. You can write x square minus x into alpha plus beta plus alpha beta equal to 0. Here a into we can write, but there will not be given a. Simply you can try to understand this one. Quotient is 1, or you can indicate this one as x square minus x into sum of roots. X square minus x into sum of roots plus product of roots. X square minus x into sum of roots plus product of roots is equal to 0 is the formation of quadratic equations. We have discussed the properties. Now let us discuss small examples. This is note 1 and put this is note 2. Let us discuss about third point. Third one. We can write the formula as, we know that alpha plus beta is equal to, we know that for the quadratic equation alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Let us going to discuss about alpha square plus beta square and alpha cube plus beta cube, which is useful to IPA. For object I will say in detailed manner later. Now using this one, you can write alpha square plus beta square. Yes, alpha plus beta whole square minus 2 alpha beta. So you can write this one as b square by a square minus 2c by a. You can write this one as b square minus 2ac by a square is the formula of alpha square plus beta square. Next we can write alpha minus beta whole square also. Alpha minus beta whole square we can understand as the formula alpha plus beta whole square minus 4 alpha beta. Alpha plus beta whole square you can write b square minus a square by this is 4c by a. So you can write this one as b square minus 4ac by mod a square. Now using this one, mod alpha minus beta. Mod alpha minus beta is notated as difference of roots. Difference of roots of QE. You can write this one as root of b square minus 4ac by mod a, or because this is alpha minus beta whole square we had written, students. Here I am writing alpha minus beta whole square. If you need mod alpha minus beta, you can write this one root delta by mod a, because this is a square in denominator. This is a square. This is also a square. Now third one, this is second one, students. Third one. Among this one, this is first. This is second, this is third. You can write alpha cube plus beta cube. Remember the formula alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. A cube plus b cube a plus b whole cube minus 3ab into a plus b model. Yeah. What is a plus b here? You can write this one as minus b cube by a cube. Here 3c by a into here minus b by a. You can understand this one as minus 3 cube plus 3abc by a cube. So alpha cube plus beta cube you can write as 3abc minus b cube by a cube. 3abc minus b cube by a cube, which will be useful in objective also. Okay students, in this class entirely I said only theory and concepts. Let us going to discuss about examples and sums which are useful in next class.